For our first problem, we have an addition of fractions. When we're working with adding or subtracting fraction, we can combine only like terms or tags, which means we have to have a like denominator. That works for adding and subtracting. They have to be the same. So therefore, we're going to have the like denominator. We have a 7 and a 5, which are different. So we can go through, count by 5s, 5, 10, 15, 20, 25, 30, 35, and 7, 14, 21, 28, 35. So 35 is going to be our common denominator or like denominator. Our whole numbers are going to stay the same, and then we're going to have to go ahead and make equivalent fractions. So 4/7, we want to find out how many 35ths that is. So we had to do 7 times 5 to get 35. So we do 4 times 5 and get 20. Then for the next one, to get to the 35, it was 5 times 7. So whatever we do to the denominator, we do the same thing to the numerator. Okay. Now, once we have this point, we can add our whole numbers, 9. We can add our numerators, 34, and the denominator was just a like term, so that stays the same. And that's already in lowest terms, 9 and 34 35ths. For number 2, we're subtracting fractions here, so we already have a like term. So we can do the 4 minus 2 to get 2, but we cannot do 2 minus 4. We always have to have a bigger number first. So we have 4 and 2/7, so we could say we have 1, 2, 3, 4, and then we have 2/7 down here. So we have enough to give away 2 and 4/7, we just don't have enough 7s. So what we're going to do is we're going to take this one right here, and we're going to break it into 7 pieces. So that gives us 7/7. So we show that here. We're taking the 4, we're borrowing 1. The 1 that we borrow is going to be cut into 7 pieces. So we have 7 new pieces here. So we have 7 new pieces here, and we already had 2 pieces. So the 7 pieces plus the 2 pieces, the 7 plus the 2 gives us a total of 9 pieces now. So now we have 3 whole ones, so that's our 3 here. And we have 7 plus 2, which gives us 9 pieces. Okay. So now we can go ahead and just do our subtraction. So now the 9 minus 4 is going to give us a 5. Our whole numbers are like terms. 3 minus 2 is 1. And our denominator is just a term or tag that's a like denominator. So 1 and 5/7. For number 3, we can do 3 minus 1 for our numerators. So 3 minus 1 gives us a 2. Subtract our whole numbers. 4 minus 1 gives us a 3. And once again, our denominator is just a like term or tag. So 3 and 2/4. Now this can be simplified. We have a proper fraction, but these have a factor in common, and that factor that we have in common is 2, which means we can divide both of those by 2. So the whole number we're not changing, but we're going to do 2 divided by 2 is 1, 4 divided by 2 is 2. And 2/4 would be like a $1/2, so 2/4 is a half, 3 and 1/2. For number 4, once again we're adding, so we must have like terms. So 9 and 7 are not like terms, so we're going to have to get a common denominator. And for this one, it would be 63. So we do that because now all we're concerned with is just doing a simple addition problem with our numerators. So now we're going to make the 9ths into 63rds. So that would be times 7. So we have to do 7 times 7. So whatever we do to the denominator, we do to the numerator. And we get 49. Then here, 7 times 9 is 63. So 9 times the 5, so once again, the most multiplied by the 9, is 45. So now we just add numerator plus numerator, and we get 94 63rds. And this is an improper fraction. So a fraction is a division problem. 94 divided by 63. And 63 goes into 94 one time. We're going to subtract. We'll get a 1 and a 3. So our remainder becomes our numerator. Our denominator, as we can see all the way through here, is remained the same, 63. So 1 and 31 over 63.